Okay, so we want to do some factoring, and I'm going to do this video a little differently than we've done in the past. So this is our problem, our trinomial we want to factor, 3x squared plus 17x plus 20. And what we're going to do in this video is look at 3 different approaches to factoring this problem. And so the first method we're going to use is going to be very familiar to you, and it's kind of a trial and error process in which we're going to base it off of FOIL. Okay? So remember when we think about that FOIL method, FOIL was used to multiply binomials together. And normally our result was a trinomial like we have here. Okay? And so remember how that was set up is we automatically go to our 2 sets of parentheses. Okay? And then we look at the first term. So remember in FOIL, when you think about F, it says multiply the first 2 terms together. So the first terms in each set of parentheses. That's going to give us the first term in our trinomial. So that 3x squared comes from multiplying the front positions. Now, in the problems that we've seen previously, it has just been a 1x squared sitting there. And in that scenario, we learned to always split that up evenly into our x times x. But now we have a coefficient. We've got that value of 3 that's sitting in front of there. That also means that when we multiply this and this, so these 2 front positions together, we got to get back a 3 as well. So what we want to think about there as far as that 3 is concerned is what numbers can we multiply together to get back 3? And the only thing that comes to mind is 3 times 1. Okay. So that's kind of nice. Since it's only one option, we're going to use it. So go to our parentheses here. One of these is going to be a 3. The other one's going to be a 1. Okay. So let's make 3x, and we can put a 1x there. Okay. Now, remember what we're going to look for is we're going to skip over to the very last term. And so L in FOIL says that the last term here of that 20 is going to come from multiplying the last positions in each set of parentheses. So that means that we need to think about what numbers will multiply together to give us back 20. So when we look at 20, one thing that might come to mind is 4 times 5. Another option could be, say, 2 times 10. And there's always that possibility that it could be 1 times 20. And then remember what we talked about before when we were doing these, is that sign in front of it told us what to do with these numbers. So not only would we do 4 times 5 to get the 20, but then we would do 4 plus 5 to get our middle term, which in this case is a 17. Okay. So remember that that plus sign that we see there tells us that we need to add. But do you know something about this? If I take 4 and 5 and add them, I'm not going to get 17. If I do 2 plus 10 and add it, we're not going to get 17. If we do 1 plus 20 and add them, we're not going to get 17. And the reason why is because whatever number we put in this back position, okay, remember like the O and the I, okay, we're going to multiply the outers. So we're going to multiply it by this 3 that's sitting there. Okay. And so we're going to have 3 times something. And then whatever number goes here, remember, it's going to ultimately multiply by that number. And so we're going to have whatever that number is times 1. Okay. So that means that these values that we have of like our 4 and 5, one of those numbers is going to get multiplied by 1. One of those numbers is going to get multiplied by 3. Okay. So let's check them. Okay. Let's just go start with our first one. Let's go 4, and let's multiply it by 1. Okay. So that would say our 4 would go here, and we would go 4 times 1. Okay. And then we're going to add, because remember this is a plus back here, so it's telling us to add. And let's take our second value, 5, and multiply it by 3, because that would say we're putting our 5 here, and we would multiply it by 3. So what do we get? So 4 times 1 is 4, plus 5 times 3 is 15. And now if we take 4 and 15 and add them together, we get 19. Now, is 19 our middle term? No. Okay. So this is a big no. It's not that. All right. But that was saying I'm putting my 4 here and my 5 here. Well, what if we switched them? Okay, so let's change the order of that. So let's take our 4 and multiply it by the 3. So I'm just going to switch those numbers we're multiplying them by, and then plus our 5 times the 1, and see what we get. So 4 times 3 is 12, plus 5 times 1 is 5, and 12 plus 5 is 17. And notice 17 is, in fact, our middle term. Okay. So notice what's happening is we're saying that the 4 has to get multiplied by 3. Well, which one's getting multiplied by 3? That is this number back here. So that would be our 4. Okay. And it's a plus, because notice we did positive 4 times 3. Okay. And then we have positive 5 times 1. So that positive 5 has to go right here, because we're going to do positive 5 times 1. Okay. So let's bring in our positive 5. And now we have it factored. Okay. I know it looks like we got a lot of stuff right here in this small space. So I'm just going to rewrite that. And we now have 3x plus 5 times 1x. I'm just going to write it as x plus 4. We now have our factored form. So pause this video for just a second so that you can look at this trial and error process that we just did. Okay, let's look at another method, but we are going to use the same problem. So that way you can see how it varies, how it's going to look for a problem whenever you change the methods. So this next method that we're going to use is what's referred to as the AC method. And the reason why it's called the AC method is when I look at this trinomial, and again, we have 3x squared plus 17x plus 20. Okay. This first number in front of the x squared, that 3, is known as A. Our coefficient in front of the x, that 17, is known as B. And then the constant at the end is known as C. Okay. So that's kind of where the AC method is going to come from for us. And what the AC method tells us to do is it says take our value of A, which is 3, and our value of 20, which is our C, and notice what AC is. Okay. A times C. So we are going to take 3 times 20, and that gives us a result of 60. Okay. Now, what allows us to do here is when we do the AC method and we multiply this 3 times 20 to get 60, it's going to allow us to figure out how can we split up this 17x to make this a little bit easier of a factoring problem for us to work with. Okay. And so what we now want to consider is when we look at this value of 60, okay, is we want to find two numbers that will multiply together to get 60 that at the same time will add to give us this middle term of 17. Okay. All right, so let's look at 60. All right, and we'll go right here first. So two numbers that will multiply together to get 60. Right? So we already know like 3 times 20 will do that. Okay. But let's look at 6 times 10. That might be something I go for. We could consider 3 times 20. All right. Means we could also consider something like 2 times 30. I'm probably not going to go for 1 in 60, but that's always a possibility that you could consider. Okay. And let's see here, 60, that's what, like 5 times 12? So let's check these out and see if any of these will potentially work for us, right? So what we're going to do is use these numbers here to replace that 17x. Okay? And so we're going to look at adding these. So if I made this like, what ultimately would happen is we're going to think that that's like a 6x plus 10x. But notice if we add those two together, we get 16x, which is not the 17x. So it's not that one. Same thing here, we got 3 and 20. So if that was a 3x plus 20x, we're going to get 23x, which is not what we're wanting. Okay. 2 times 30 gives us the 60. So let's make it a 2x plus 30x, which is 32x, which is not the 17x that we're trying to get here in the middle. Okay. And how about 5 times 12? So that's a 5x plus 12x. That is 17x. So that's what we're looking for. Okay. So what that tells us is that we are going to take the 17x that's in our problem to start with, and we're going to replace it with a 5x plus 12x. Okay. So let's change our problem. We're going to keep our 3x squared. This 17x is going to be replaced with a plus 5x plus 12x plus 20. And now this is going to be something that we can factor. Okay. Now, I just placed these terms in here. So I'm just replacing that 5x plus 12x adds back together to give me that 17x. Okay. But what I want to look for here, okay, if I have 3x squared and 5x, can I sort of compare those two? And then can I compare 12x plus 20x? Or do I need to change this a little bit? So what I'm going to look at here is, like, I noticed that 3x squared and 5x both have an x in common, but there's no number that will divide into 3 that will also divide into 5. So let's check this out. Okay. Over here, I've got 12 and 20. Okay. Will that work? That'll work, won't it? 12 and 20 are both divisible by 4. Okay. And so let's see what happens here. So what we're going to do is look at just a piece of this at a time. Okay. So I'm going to ignore that part of the problem for a second. Okay. And I'm going to look for see what they have in common. So I'm kind of factoring out, but I'm only going to factor out kind of based on distributive property. And so I'm going to see that this has an x and that has an x. So I'm going to bring out an x that they have in common. And so what's left over? So x times what gives us back 3x squared? And so that would be our 3x. Bring down our plus, and kind of same thing here. X times what would give us 5x, or we can think about 5x divided by x. If I take that away, I'm going to have 5. Okay. All right, now ignore that. And here we have plus 12x plus 20. Now 12 and 20 are both divisible by 4. So I'm going to bring a 4 out. So let's bring out plus 4. Okay. Open up our set of parentheses. 12 divided by 4 is 3. And then we're going to keep that variable of x. Bring down our plus. And 20 divided by 4 is 5. Okay. So now when you look at this problem, right, do you notice anything that appears in this product? Because notice it's x times 3x plus 5. That also appears in this product of 4 times 3x plus 5. Yes. You are going to notice, or hopefully that you notice, that there is this 3x plus 5 in parentheses here. And there's also a 3x plus 5 in parentheses here. So what that tells us we can do is that they have that in common. So let's bring out that set of parentheses of 3x plus 5. Let's open up a second set of parentheses, and we're only going to pick up what's left over. So what's left over is the x that's out in front and the plus 4 that is out in front. And so now we have our factored form of 3x plus 5 times x plus 4. And so this is your AC method. So again, take a moment, pause the video here, and just kind of look to see what's happening in this particular strategy for factoring a trinomial. Okay, I got one more method for you. And again, same problem. So this method here is called the slide and divide approach. And so notice that our trinomial is still 3x squared plus 17x plus 20. Okay. What slide and divide says is it's going to tell us that this 3, that coefficient of 3 that's in front of our x squared, is kind of what's making the factoring a little bit more challenging. And so it tells us to slide it. And we're going to slide it all the way to the back. And we're going to multiply it with that 20. Okay. So we're basically going to remove it from the front here. Okay. And so it's going to become just an x squared. We aren't doing anything at all to that plus 17x, so we leave that as is. But what's going to take place here as we bring that 3 back, we're going to multiply by 3. So 20 times 3 is 60. Okay. Now what we're going to do is we're going to factor this problem. Okay? And so we're going to think about FOIL. So we're going to go automatically to our 2 sets of parentheses. We're going to start with our first term because that comes from multiplying the 2 front positions together. And so remember, with x squared, we always split that up evenly as our x times x. Then we're going to skip all the way over to the last term, which is 60. And that's going to come from multiplying the 2 back positions together. So when we're working with 60, we're first going to think about what 2 numbers can we multiply together to get 60. So we could think about 6 times 10. We could consider 3 times 20. We could think about 2 times 10. We could think about 5 times 12. And we could keep on going. Okay. So the next thing we're going to look at is the sign in front of our 60. It's a plus. So that's going to tell us to add these 2 numbers together. And we're going to add trying to get this middle term of 17. Okay. Now we're going to do that here because remember, this is a 1x squared. So when we start multiplying this all out, the only way we're going to get that middle term, remember, we're going to multiply these 2 together. So the 2 innermost terms and the 2 outermost terms. But these are 1s. So it's not going to affect these numbers here. So if we add them, 6 plus 10 is 16, which is not our middle term of 17 that we're trying to get to. 3 plus 20 is 23, which is also not that middle term. 2 plus 30 is 32. So again, not the middle term. And then 5 plus 12, which is 17. So that is the middle term that we're looking for. So we're going to use 5 and 12. So I'm going to bring in the 5 and I'm going to bring in the 12. And they had to be added, right? So adding to get the positive 17. So that means that they're both going to be pluses as well. Now, this is not our answer, okay? But it's getting us a step closer. So notice that if we multiply this back out, we're going to get this trinomial. But remember, our original trinomial had the 3 sitting out in front of the x squared. And so what happened here is, remember, we multiplied by 3. So now we got to get rid of that 3. Okay, so the opposite of multiplication is divide. So that's where the divide part comes in. So it was that constant back here, that last term that got multiplied by 3. That means that this 5 and the 12, they have to get divided by 3. So we're going to divide by 3, divide by 3. And as we do this, we're going to simplify. And so what I'm going to look for here is 5 over 3. Will that divide out to a nice whole number? And it doesn't. So what's going to happen here is I'm going to take that 3 and I'm going to slide it back in front of that variable of x. And so we are going to get a 3x plus 5. Second set of parentheses here, we have the x plus 12 over 3. But notice that 12 over 3 will divide out to a nice whole number. And so that's going to be a plus 4. So we get x plus 4. And we now have our factored form. So our 3x squared plus 17x plus 20 is going to be 3x plus 5 times an x plus 4 factored. And this is your slide and divide approach. So you have 3 different methods to choose from. You have slide and divide. You have the AC method. And you also have trial and error. Okay? So it's your all's decision. Okay? Pick a method that you like and work problems out using that. And there's nothing that says that you can't work one problem using trial and error, and then maybe try slide and divide on another, and maybe AC method on one.